I can keep that shorter, so I don't have to put that on the video.
Easy.
All right, thanks everybody. I'm Doug Sillars. I'm originally from Seattle, Washington, but I've been traveling around Europe with my family for about 2.5 years. And we're going to talk about fast and beautiful images. A little bit about myself. I do freelance developer relations, so I help companies figure out how to talk to developer communities. I also do a lot with performance, helping to speed up the web, helping to speed up native applications. And I do workshops on performance, on images, on video. I'm working on one on AR and VR on the web as well, which is really cool. So I need to update this slide. A few years ago, I wrote a book on high-performance Android apps. And if you're interested in how to speed up your Android app, that's the PDF of my book. I'm going to post this. I actually already posted the slides on the meetup. So if you're interested, you don't have to take pictures or anything. All of this stuff is already online for you to see on the meetup page. And then if you ever have any questions about any of this, I'm the only Doug Sillars on the internet. So I'm really easy to find: Twitter, email, etc. But before we really start getting into images, how many of you sort of get nervous thinking about walking across this cliff that's literally nailed into an Alp in Switzerland? All right, a bunch of hands, right? Yeah, I mean, this is called First Cliff Walk, and I walked across it with my family. And my then 6-year-old decided to jump the whole way. So it had this nice rattling effect that was also really, really nice. But a few years ago, Ericsson did a study. And in this study, they put sensors on people's heads to measure stress responses to different stimuli. And they found that thinking about walking on the edge of a cliff was really, really stressful. But actually, a slow mobile website is more stressful than thinking about walking on the edge of a cliff. It's the same as solving a math problem. Also equal on that was watching a horror movie. So that stress you feel when you watch a horror movie is what people feel when they go to a slow website. Google found that a 3-second delay causes 50% of your users to abandon your mobile website. A half-second delay increases frustration, lowers engagement. About 20 years ago, both Amazon and Walmart found that every 100 milliseconds costs them 1% of revenue. And then my favorite stat of all is 4% of mobile users admit to throwing their phone when there's a slow mobile website. So like, people don't like slow, so we shouldn't do that, right? If you're trying to build an e-commerce site, you know, if you go to the mall, it's always happy music, really bright lights, keeping everybody cheerful, because when you're cheerful, you spend more money. But if you're frustrated and less engaged and angry, you're less likely to buy things. So what can we do to speed up websites? Well, it turns out, if you look at the average web page, and this is looking at 500,000 websites, the average website is 50% images. So if we can make the images smaller, deliver them faster, we're going to speed up the web pages. You may notice that on this graph, video is 25%. Most web pages don't have video, but video files are so large that it's sort of like the joke, if Jeff Bezos came and sat right over here, our average salary would be $100 million a year. The few websites that have video throw off the average for all the other websites, right? That's why video looks like it's so big. So let's look at how we can speed up the images that we're delivering to web pages, to mobile apps. Because if we can speed that up, we're going to speed up the content. It'll make our customers happier. They'll spend more money, which means, of course, that our jobs are safe. Anyone know Lighthouse? A couple hands? All right, so Lighthouse is a Google tool. It's in Chrome DevTools. It's also in Web Page Test, which I'll talk about in a second. And what it does is it goes through and audits your web page and then looks for ways to speed it up for mobile. So it's a really good tool. If you're interested in how to speed up a web page, run a Lighthouse audit. And there's 4 optimizations for images in Lighthouse: quality, format, sizing, and lazy loading. And you're graded. When I wrote the deck, it was from 0 to 100. They just changed their scoring from 0 to 1, divide by 100. We can all do that math, so it's not hard. So what's also really cool, Web Page Test. Any Web Page Test users here? No, oh, I see a couple nods. But anyway, webpagetest.org, check it out. It's an awesome tool to test how fast your web page is. You can test in locations all around the world, so you can load your web page in America, in Europe, in Asia. You can use mobile devices, you can use Android, iOS, you can use Chrome, You can use Firefox, you can use Safari, right? Any type of device, you can see how your web page loads. You can slow down the network, speed up the network. It's really awesome. And what's really cool is there's another tool called the HTTP Archive that scans 4 million websites every month, and it runs web page test and Lighthouse on 4 million web pages. So what does that mean? That means that we've got a database with 4 million web pages with all the Lighthouse data on how images are doing on the web. So now we can figure out what's happening on the internet today when it comes to images and how that optimization could actually affect things. So let's walk through these 4 optimizations that come from Lighthouse. The first one is quality. And Google recommends that you save all of your images at 85% quality. So if you're in Photoshop and you're saving a JPEG, you always see like there's a quality slider. And you can lower it to 85%. And Google says that's good enough for the web. In general, no one will ever see a difference. If you don't want to do it in Photoshop, ImageMagick will do it. You just set the quality to 85 and it saves a new image for you. If you wanted to use a cloud provider, you can upload the full-size image to Cloudinary, and it'll give you a URL, and then you just add this Q85 parameter, and it generates the quality 85 image for you on the fly. So that's a really cool way to do it. And so you may see it says Riga here. Here's Riga, right? 3.6 megabytes. If I save it at 85%, it's half the size, 1.87 megabytes.
Oh, this projector, you will not see the difference.
You won't see a difference on this. We'll get to an image where you can see the difference. Every projector is a little bit different, so I try to go to a few extremes. So if we look at Lighthouse, what's going on in terms of 85% image quality? 33% score is 0. Which means they're not doing any image optimization. 33% of all websites are doing nothing. 43% are passing. So, you know, there's a lot of work that can still be done here. Over 50% of websites can do better. Lighthouse also tells you how much faster the web page will be if you do this optimization. So if we look at the web pages that fail, the median web page that fails would be 2.8 seconds faster and save 420 kilobytes of data. Right? So if you could go to your boss and say, hey, I can make our web page load 3 seconds faster and use 400K less data, that's a pretty good, you know, benchmark that you can speed up the web page. But could we do better, right? 85% is the recommendation. It works for most images. So let's look at 50%. This projector, maybe you can't tell the difference. On some projectors, you start seeing some kerning in the sky. If I take it to 20%, for sure you're going to see it, right? You can see the bars in the sky, right? That just looks horrible. You wouldn't do that. So we know 85% is bad, or 85% is good, 20% is bad, but where's the sweet spot in the middle? Can we do this automatically? We don't want to have somebody like scanning every single image that's going on the website and looking to see what the right quality level is. But there are algorithms that will do this for you. There's math that can do this. There's 2 tools. Google has DEVCLUB.EE. All the Google compression engineers are in Switzerland, and they name all their compression algorithms after pastries. So DEVCLUB.EE is a type of pastry, but it's also a way to optimize images. It's a little bit slower than structural similarity. They both do the same thing. It lowers the image quality to where the human eye can't tell a difference, right? And if our eyes can't tell a difference, why not squeeze out a few more 100 kilobytes out of your images? Because nobody knows. So that's an open source tool that'll do it. You can also do it with Cloudinary, right? There's a lot of easy ways to do this. The Riga image is now 400K smaller. It's now 1.46 megabytes. And you can't tell a difference on this projector, but you can't tell a difference on any screen anywhere. Just because the human eye can't tell a difference. So, you know, we say 400K. But what does that look like in real life? This is web page test. And I actually just loaded those images in web page test on a 3G connection with a real Motorola device. In Virginia, they're not emulated, they're actually real devices connect up to web page test, which is a really great way to do your testing. The full-size image is 3.7 megabytes, takes almost 22 seconds to download. Structural similarity, I'm down to 9.5 seconds, 1.5 megabytes. But we're still going to go better because 1.5 megabytes for an image is still too big. Luckily, I have 3 more optimizations. So we're going to go to format next. A lot of different image formats out there. This is the average data out on the web. Most of the images out there are JPEGs. JPEGs are also the largest file in general. But let's talk about vector graphics, SVGs. SVGs are awesome. They're shapes, right? They're vectors. And they're infinitely scalable because they're shapes, and it's basically an XML document. And so this is the Twitter icon as an XML, or as a SVG. And you can stretch it out as much as you want, and you can't tell a difference because they're just shapes. You make this circle bigger, it's a bigger circle. If you see any idiosyncrasies here, it's because PowerPoint doesn't support SVGs, so I had to actually take a screenshot of the SVG to put it in the PowerPoint. On some projectors, you can actually see it looks pretty bad. But I found this SVG on the internet. It's a target, essentially. And if you look at the XML, you're basically drawing a bunch of circles. And that's fine, you're drawing a bunch of circles. But if you look closely, it says Adobe Illustrator, and then you see a bunch of metadata. And you might be wondering, well, how much metadata does Adobe Illustrator put in there? The file was 946 kilobytes. I go in there, I click right here, drag to the bottom, delete it, save it again, 1 kilobyte. So the moral of that story is test your images before you push them live. And if they seem really, really large, maybe you can make them a little bit smaller. And in this case, they pushed this live. This is live on the web page. I just checked it last week, and it's still there. This is an XML file, so you can gzip it. Or you can use Brotli, which is bread in German, right? It's a Google algorithm, right? It's a pastry. So you could take this image from almost a megabyte to half a K. And wouldn't you much rather serve half a kilobyte for an image than, interestingly, they also serve this as a PNG. So when you load this web page, you get the 2 kilobyte PNG and the 950K SVG. They download it twice because I guess 2 downloads is better than, no, 1 download is always better than 2. They also have it in orange, same deal. So we're talking about 1.8 megabytes of circles on one web page. What's cool about SVGs is you can actually style them. So if I take the red one and I just apply this style to it, it turns orange. So I could do 500 bytes of an SVG, 1 style, and I've got 2 images. Or I could download 1.8 megabytes of these, right? This is sort of just testing, right? You should always test your stuff before you go live. I was tweeting this weekend, I found a web page that has a background video, but they forgot to autoplay the background video. So it downloads the entire video. There are no controls to start or stop the video, and it doesn't play. So it's basically a 28 megabyte brick on this mobile web page because no one can see the video, it just downloads all the time, right? This is sort of like, did they test it? Like, it's been live for several months. I went back in history, and it's been live for a long time, and nobody looked. Test your stuff when you push it live to make sure you're not doing things like this and you don't end up in my talks where I'm making fun of somebody's web page. So WebP is another format. It's an image format. It's newer than JPEG. JPEG's like 30 years old, right? JPEG's been around forever. WebP is about 7 or 8 years old. WebP is essentially a one-frame video. It's based on VP8 video, but the compression for VP8 was so great, they're like, we'll just make an image format out of it. WebP is a one-frame video. And a year ago, support for it was Chrome and Android. But if you look now, we've got Edge, we've got Firefox, they're working on it in Safari. So by a few months from now, we may have all the major modern browsers supporting WebP. So it's probably starting to think about being worthwhile to look at WebP as a format, because if I take that Riga image that I've optimized to 1.4 megabytes, it's now under 1 megabyte as soon as I turn it to a WebP. So that saves another 400, 450K just by changing the format of the image. And you can see it shaves off 2.5 seconds from 9.5 to 7 seconds on the load time on a 3G connection. And so, of course, building on the web, you can use the picture tag, serve the WebP. If the browser doesn't know how to deal with the WebP, it'll show the JPEG. And if you have somebody who can't see either types of those images, you get an alt tag. So you should always have an alt tag. just for accessibility. If we go back into that HTTP archive data, we see a full 2/3 of the internet aren't using alternative formats. They're just using JPEGs. And by switching to alternative formats, the median web page would be 4.1 seconds faster and use 600K less data, right? I mean, 4 seconds faster on a 3G connection, that's a pretty huge speed up. It's something we should look at.
What about HTTPS?
HTTPS? So this isn't looking at HTTPS. If you're using HTTP2, in general, you're going to speed up the delivery of content if they're all on the same domain. Because what HTTP2 allows us to do it on one connection instead of many connections. So in general, it will be faster. I don't have any data on that here in the talk, but yes. The last one makes the most sense probably to everybody. Image sizing. You serve a different size image to the laptop than you do to the mobile device, right? Because it wastes data to send desktop images to mobile. So let's look at that. I take this image. It's 13 megapixels. It's 1.6 megabytes. I do all the stuff we just talked about. I get it down to 800K. But then it's still 13 megapixels. And I'm going to serve that to a mobile device, which of course means that it downloads 13 megapixels. It shows 500,000 pixels, which means it has to throw away 12.5 million pixels. Right? It has to download all of that and then throw away 95% of the data it just downloaded. It's like when you order a box from Amazon and you have to pull out like 8 meters of paper and bubble wrap and everything before you find the package at the bottom, right? You get this giant box and it's all wasted packaging and there's only one thing in the bottom of the box.
But it's fun.
It's fun, right? Especially the bubble wrap. My kids go nuts, like it's great. But we always laugh when we get those giant packages. And so and when it's on a mobile device, it's incredibly wasteful because not everybody's on an unlimited data plan. In December, I got to go to Russia. And I was just curious how much it would cost to roam. I was using an Irish data plan. And it was 10 euros 24 per megabyte. Right? So this image would cost me 16 euros just to download the image, right? We don't want to do that. I mean, that's an edge case, but there's always going to be somebody on your web page with that edge case.
Probably you know that all browsers right now are using the optimization, image optimization, HTML optimization.
No browsers are doing HTML optimization.
Chrome.
What sort of optimization is Chrome doing?
They're doing the optimization of pictures.
If you have data saver turned on.
Of course.
But you have to have data saver turned on.
Of course. But I think right now they have a notification about it, and this is in general automatic.
It's not automatic because you have to go and turn on data saver in your browser.
Okay.
And so I have data later on that shows it's only about 5% of people who have that turned on. Okay. So for those 5% of people, we'll talk about how that's great. But for everybody else, this is something that you should worry about. And data saver won't save you from that web page that's downloading the entire video.
But look, there is another issue that many operators, telco operators, they already have an optimization inside based on DPI or based on proxy server.
So
they already have optimization in mobile network, for example.
So I worked for AT&T for 10 years back in the States, and there were always companies trying to sell us that sort of product, a product that would mess around with our customers' content, make it smaller, and then send it to our customers. And we always said, no, we don't want that on our network because inevitably that's going to break a web page.
Do you know the company INEA?
No, I don't.
They acquired 4 years ago the company OpenWave.
Okay.
They are doing also optimization, video optimization, page optimization. Actually, AT&T uses it.
Well, so video stuff is different, and I can talk about the video stuff in a second. But there's actually an example where T-Mobile in America decided that they were going to optimize all the JavaScript that was coming over their network. And they thought the best way to do that is to remove all the comments. So if they see a JavaScript, they just go through and they cut out all the comments. Well, it turns out in jQuery, there are a bunch of places in the code where there's a star and a slash and then a slash and a star. And they were actually cutting out large swaths of jQuery on all of these web pages. And it broke every single web page that used jQuery on the T-Mobile network. And so like the idea came out of a good place, but people build things in very weird ways. I met a company that once that was building a mobile application, and they had a 404 on every single page, and that's how they were doing their analytics, by measuring their 404s. And I was like, there's a lot better ways to do that, but that's the way they wanted to do it. So everybody does weird things. So imagine if the carrier blocked all the 404s, they'd be like, we have no traffic coming from all of this cellular network, right? People do weird things, and if you apply something across everything, you're gonna break stuff. So yes, there are, in America, they do throttle all video. They throttle all video to 1.5 megabit per second, and they make the video free. There are ways that they do it. In general, some carriers do images stuff, but that isn't everybody, and you're gonna have edge cases where it doesn't work for everybody. In general, I think it's better as a developer that we fix it on our site, because if it's optimized and we know it's working on our web page and in our app, then the carriers won't mess around with our stuff, and it'll work. But there are always examples of carriers being a little heavy-handed in breaking stuff. And so when I worked at AT&T, I had a couple allies where we always said, we don't want to do that because we're going to break things, and then it's going to be horrible press. So I hear what you're saying, and there are carriers that are doing that stuff, but that's not going to fix it for everybody else. So if you want your site to be fast for everybody, you don't really want to rely on other people like, let's muck around with their code and it'll be faster. You should probably do it on your own so that it's fast for everybody. And going back to this example, in this case, the CPU, so we download 13 megapixels of data, and 12.5 megapixels have to be thrown away. That means that the CPU on your phone has to fire up and do a lot of math to figure out what to throw away. And do you guys know, have you heard of Android Go? So Android Go are these really low-powered devices that you can buy really, really cheaply. And the Alcatel One X is under 100 euros. It's a 2018 phone. It's got a really crappy screen. It's got a really low-end processor. It's a really low-end device. So downloading this image takes about the same on the desktop, the Motorola G4, and the Alcatel One X. But look how much longer the image decode takes. Because it's got such a crappy processor on it, it takes almost a second for it to throw away those 12 million pixels before it can show up on the screen. So not only do you have to wait all this time to download it, but then you have to wait for the CPU to slowly chug through all the pixels and figure out which ones end up on the screen. So on really low-powered devices, this is a big issue. The Alcatel, or the Android Go devices, #2 markets, the United States. So you might be thinking, oh, it's all just going to be in India and China. We don't have to worry about it. But the United States, Russia are really big markets for these Android Go devices. And you can find them here in Europe, too. They're really cheap. It's when you go into the cell phone store and you see the Pixel 3, it's plugged in. You can play with it. You see the next line of phones. You can play with them. It's the phone way at the end that isn't plugged in because they don't want you to play with it because it's so bad. But the price is great. Like, under 100 euros, that's awesome. So how do you resize the images so they work on all the different devices? These are all the Android devices that hit Akamai in one day. The size of the box is obviously how many devices. The color is how fast the CPU is. So you can see there are all these Samsung devices that are green here, right? Samsung is the biggest Android. You can see there are a lot of red devices down there in the corner. And so of course, responsive images are the answer, right? Generate a bunch of different size images so that you get the right size image for your for the mobile device in question. In this case, I'm generating a bunch of images that are 25K different in size. I'm going to generate 20 different images. That may be too many for you guys, right? Maybe you only need 3, maybe only 4. look at your analytics, see what your customers are using, and generate those images. But now when I generate the right size image, now I'm only wasting 100,000 pixels instead of 12.5 million. There's free tools that'll do this for you. You can make it just part of your, your content management. Every time you upload an image, resize the images. And so this is the web interface. Smallest one is 200 pixels wide, biggest one's 1400 pixels wide, 25 kilobytes apart. The HTML is a little ugly, but it'll serve the right size image to the right size device. And now, because the image is optimized to the size of my mobile phone, it's now 120K, and I shaved another 5 seconds off the load time. It's now just 2 seconds for that image to load. This is reasonable. 120K for an image, that makes sense, right? It's not going to kill anyone's data plan. We're talking more of a reasonable size. And then if we look in the HTTP archive, over 50% of the web is doing it right. 60% is passing completely. A fifth are failing. So of the fifth that are failing, again, we're talking 2.7 seconds faster, 400K less data, which is really, really neat. The last example is lazy loading. And there's actually been a lot of talk about this really, really recently, and I'll explain why. But the idea behind lazy loading is if you have a web page that looks like this, only load the images that your customer is going to see, right? If I only have to load 2 images instead of 6 images, the web page is going to load faster because those images aren't going to show up right away. Then you can use JavaScript to know when those come into view and you load those images. Yes?
How do you know this JavaScript doesn't take longer to load than these images?
So it's a lot less. So the lazy sizes is what I used here. I think it's like a 2K JavaScript package.
Yeah, but overall, JavaScript in 2019 is like a lot of data to load.
No, but I'm saying this library itself is 2K, and 4 images is going to be more than 2K in general. So this is faster. I mean, if you had only small images, maybe not, but in general, the savings of not loading 4 big images is going to be faster. If we look, most web pages, when I ran this, were not doing it. 60% were not lazy loading. The median page on 3G would be 3.5 seconds faster, use 500K less data. So what do you do when you're doing lazy loading? Often you have placeholder images. So this is image search. You search for cats in costume, and you get these placeholder images where the color matches the primary color of what's showing up. So it's green for the cat dressed up like a dinosaur. It's pink for the bunny rabbit cat, right? As a customer, you start to know, you see these and you know an image is coming. You expect that an image will come into its place. The other nice thing about this is, when you're reading an article and images start popping in and the text moves around and you have to figure out where you're reading, this isn't going to happen anymore because you've got all the placeholders in place. You can go fancy with placeholders. This is an SVG of the waterfall. So instead of just being green, you can sort of see some texture to it. It's an open source library. It's really fun to use. You can again make this part of your content loading strategy. This is like 500 bytes compressed. Just put it in your HTML. And then when the waterfall loads in, that disappears. You get the waterfall. It looks really awesome. So this is a desktop web page. I've just zoomed it way in. So you can see the different views that you would get when you load this on your desktop. And so this is above the fold, right? This is what you see when the web page initially loads. So if you load this in Chrome today, you see all the text load, and then you can see the text reflow as the page loads in, right? It slowly goes down. You see the images start to pop in, but you notice that the images up here haven't loaded yet. But you've got this cow that's loaded down here at the bottom. And you've got all these images down here, and this image still hasn't loaded. And so as a user, you want the images at the top of the screen to load first, right? That's what's most important. Well, currently behind a flag, there's lazy loading in Chrome. And so what it does is it requests the first 2 kilobytes of every image on the page. And in the first 2 kilobytes, it gives you this dimensions of the image, where it's located, and the number of kilobytes of the image. So the entire page lays out immediately. You get the entire page laid out, and now the browser knows where all the images are. And because it knows where all the images are, it can load the images from top to bottom. So if you notice in number 4, all the images above the fold have loaded already. And then the images are loading down from top to bottom, which makes sense because that's the way we all consume web pages. Now, why this is in the news lately is this is actually going to roll out in Chrome 75. So in the next couple weeks, this is going to be live. And by default, the browser will decide how to lazy load the images. So you don't even have to change anything to your web page. It will do something like this and lazy load the images, which is pretty exciting that the browser will take care of that for you. Again, your mileage may vary. You should make sure that it's doing it right. But it's pretty exciting that it's coming to that browser. And hopefully it will soon follow in Safari and everybody else. I guess that's one advantage to Edge moving to Chrome is that it will get that as well, right? So everybody will get, if it's in Chromium, it'll be in those browsers. So that's a pretty exciting way to load your web pages faster because the content that your customers consume will load first. This brings us to animated GIFs. And so this is Nora the goat. She was our goat back in Seattle. And I took this movie, it's 1.4 megabytes, and I turned it into a GIF because we all need more GIFs on the internet. But when I turn it into a GIF, it's 3.8 megabytes. It's almost 300% larger. And so why is it larger? Well, if we go back 30 years and we read the spec for GIF, it says GIF is not intended as a platform for animation, even though it can be done in a limited way. So like they're saying don't do animated GIFs, but the whole world revolves around animated GIFs. So what do we do? And why are animated GIFs so bad? Well, the reason they're so bad is they're literally, if you have 30 frames per second in your GIF, it's literally 30 GIFs that it flips through every second. It's like one of those flip books that we drew when we were kids, right? It's literally just flipping through static images. There's no compression through time. Whereas movies have compression through time. So if I take that GIF and I turn it into an MP4, there's no audio track, it's 256 colors, it's 250K, as opposed to 3.8 megabytes, right? So that's huge. That's a huge savings. But you know, what about the rest of the internet? You know, Twitter uses GIFs. For those in the back, it says GIF down in the corner on Twitter, right? They're lying. It's actually an MP4, so you can open it up in DevTools, and they're serving movies. So it's GIF the medium, not GIF the format. So like GIF the medium is great, but always serve it as a video. So if you ever load a GIF in like Facebook or in Twitter or in Slack, it's probably just a looping movie. And the reason it's a looping movie is if you see over there, it's 400K for this GIF. If it was actually a GIF, it'd be like 3 or 4 megabytes. So obviously it makes sense to serve it as a movie because it's going to be way faster. And of course, the way you serve that is in a video tag, loop autoplay, right? Because it's going to loop and you want it to autoplay. You have to say muted. You have to say muted for mobile Chrome and mobile Safari. Videos won't autoplay unless they're muted on mobile. And I think that's because Safari and Chrome engineers sit in meetings too. And sometimes when they get bored, right? You don't want the video blasting out when you're in a meeting, right? We've all been there. We've all been there. Plays in line is so that it works right on Safari. One cool thing you can do in Safari is you can actually put videos in the picture tag and it'll work. So in Safari, it'll actually loop the video. Chrome will get an animated WebP and everybody else gets the animated GIF. And why that's really important is the video loads in 4.5 seconds. That's crazy fast compared to the animated GIF that takes 22 seconds. The animated WebP is, you know, at 19, so it's not that much better. So, you know, whenever you're doing an animated GIF, always turn it into a movie because you're going to save a lot of, it's going to download a lot faster. It'll show up on the screen a lot faster. And so, what are our customers saying? This is the save data header. So we were talking earlier about the data saver in Chrome. So if you go into your Chrome settings on your mobile device, you can turn on data saver. And what that does is everything that's HTTP goes through Google and they resize all the images for you. So like we were saying, Google will do that for you. If it's HTTP, if it's HTTPS, Google can't see it. It just goes straight to your device. So if you haven't optimized that image, Google won't do it. It just goes through HTTPS and you get it. But it adds a header. And then your phone is telling every single server, save my data. And if you see that as a developer, if it says save my data, maybe you should serve less data to them. Your customers are saying, I don't want all of that stuff. And here's that stat saying that 5% of users have saved data turned on. I think this is from October, but it probably still holds, right? 5% of his users say save my data. And so you could imagine, what if you're this website, the BBC, what if you just hid these 3 images for people who have saved data, right? You're not changing the content that much, but you're making it smaller for people who don't want all of that data. I talked about saving it as quality, the auto format. The Cloudinary tool, if it sees that you have saved data turned on, it turns it to Q Auto Eco. It's more aggressive, and it makes the image another 50K smaller. So there are a lot of ways you can be maybe a little more aggressive with the compression, make those images smaller, maybe hide the videos. When I spent my month in West Cork, Ireland, my Airbnb said it had Wi-Fi, but it didn't tell me that it was connected to a 3G router that was actually on edge. Right? I had high-speed Wi-Fi that was, I was pinging Google, and I had a round trip of 490 seconds. Right? I could work really great at like 1 in the morning when everybody's phones went to sleep. But I didn't see a single video on my Facebook feed that entire month because Facebook knew I was on such a crappy connection that the videos wouldn't play. And if the videos wouldn't play, I'd get frustrated at Facebook and I'd stop using Facebook. So if they're saying save data, don't serve them the big content because they don't want it. And the Network Info API is sort of what I think Facebook was using for me when I was in West Cork, because it will actually tell you the speed of the network, right? So if you call this in your JavaScript and your customer's on 500 kilobits per second network connection, which is actually faster than Edge. I was on a slower connection than that for a month. It was really interesting. It really makes you really care about performance a lot more when you're on a really slow connection for a while. But if you see that your customer's on a really slow connection, serve them smaller images, right? Hide the video. Make sure that the page is going to load quickly because you don't want to have that sort of experience for your users. Another thing that I've seen people try to do to make pages smaller is to encode their images as base 64. And you should never do this. Just never do it. The original idea behind it was you had fewer requests, right? Because you just put all of your images into your HTML. But with HTTP 2, that isn't as important anymore. When you base 64 encode your images, you're now blocking the rendering of the page with these images. The images are bigger. You can't cache them as well because they're part of your HTML, they're part of your CSS. And they're difficult to reference more than once because it's just like this blob of code. I found this CSS file on the internet. Each one of these highlights is a base 64 encoded image. It's the same star, repeated 16 times in one CSS file. And I think it's because you can't really tell what the hell it is. It's just a blob of text, right? You don't really know what it is. Now, if you notice really carefully, see how this is the same size, the non-highlighted text? Yeah, that's that star, 16 times through the entire web page, right? They're wasting all of this data, right? It's just making the file so much larger, and you don't have to do that. So, in conclusion, optimize your images for quality, format, resize them, lazy load them. Look for this in Chrome 75, it's pretty cool. Turn your animated GIFs to movies. Don't base 64 encode your images, and monitor what your customers are asking, right? If they say, smaller images, go for it. I also have a video talk, but this talk keeps getting longer and longer, so I had to split it up. So I've got a bunch of video best practices too. If you want to talk video, I'd be happy to afterwards. Bunch of tools out there that I used. Again, the slides are live on the meetup page, so if you just want to look at the slides, you can do that. Images can be beautiful and fast. Just follow some of the steps in the talk and you'll see how to do that. If you're interested, if you love building with images and video, Cloudinary is starting a media developer expert program. You can email them and they have extra perks and stuff if you're really doing a lot with media. So feel free to reach out to them if you're interested. And so with that, thank you so much for listening. I appreciate it. I'd be happy to take any questions.
Thank you, Doug, so much. We have a bit of time for questions. So if there's any in the audience.
One question.
Yeah.
You talk about this network info thingy.
Mm-hmm.
Is this a header that Chrome sends, or is this some sort of?
It is, you can query it. So you can, the JavaScript can ask the browser for it in Chrome.
It's a part of JavaScript.
So if your JavaScript says, hey, what's the network speed, you can get that number and send it back to your server.
You can use this API on your front end.
Okay.
You can use it on your front end and then report it back to your back end and then optimize based on that, yeah.
Yes, so
Yeah.
there is.
So in your final list of like your 4 things of things to do, is it a case of you best practice you ideally wish to do all of them, or you wish to do only a number of things?
So it's one of these things that's a case of diminishing returns over time. So the first optimization is going to get you your biggest win. Each subsequent one is going to be a smaller win. I would say the first one is probably sizing, because the last thing you want to be doing, and I see this happen a lot, is serve like 4 megabyte thumbnails to a mobile device, right? So if you can resize the images for every single device, you're going to really do a big chunk to optimizing all of the images. Once you go beyond that, there are additional incremental savings for each one of them, but it's always that first optimization that makes the biggest savings, and then the other ones are incremental on top of that.
Some of those resources and the links to them,
Mhm.
do they facilitate bulk optimization, or is it something that you would have to upload one by one images that you wish to change?
So lazy loading, obviously, it's just JavaScript. You put it on the web page, it'll optimize that. For redoing the formatting, I would do something like ImageMagick or Cloudinary, so it is on an image by image basis. It may be something that you start with, right? So if you have like a news organization, maybe you start with the new images going up, right? Because obviously the images from yesterday's news are going to get hit less than the images from today's news, and eventually those old images just get archived, right? I mean, eventually they don't get hit as often. So if you start just with the newer content, optimizing them, right? So there's a new news article, something about Brexit, and there's a new picture of the Prime Minister of the UK. You optimize that image, and then you don't worry about all the other images about Brexit from the last 2.5 years, right? You just worry about the newer ones. So I've seen people do that, where they just worry about the newer images, let the older ones slowly become less and less, because they're just not hit as often. Yeah, go ahead.
Is SSM and ImageMagick the same, is what I gathered from your presentation?
So ImageMagick, it's an open source, they're all open source tools. I don't know if ImageMagick does not do structural similarity. So ImageMagick will do a lot of image optimizations. It's a desktop command line tool. It will do a lot of optimizations for you. The structural similarity tools are different tools that will do the structural similarity. So it might have to be a pipeline where you have to do a couple things at once for these images. If you're using the cloud-based tool like Cloudinary, you can actually do them all at once. You upload the full-size image, and I'll just do a quick demo because I think it's really cool. Right, so I have this image. I think I'm still on the Wi-Fi. Is that okay? Is it not showing up on the video anymore? All right. Yeah, or hotel Wi-Fi, right? Right, it's one or the other. Yeah. All right. So we can go the old. Oh, it's loading. There it is. All right. So this is here's the full size image. Whoops, I broke it. All right, so here's the full-size image. And then if I wanted to do all those optimizations, I can do the quality auto. I can do the format auto. I can set the width to, I don't know, 200 kilobytes wide, or 200 pixels wide. And I broke it. What did I do wrong?
Maybe do it before, between quote and out.
That's where it is. Back. It should be right there. All right, well, there's the 512. I probably just typed something in wrong. We'll make it 200. And it generates it on the fly, right? So it's pretty fast. So this is a cool tool if you wanted to do them all at once. A lot of content management tools will do this for you. You can specify to optimize as part of the upload to just do them, to do it automatically.
You say these slides are on the meetup?
Yes, they are, in a comment.
Okay.
You can also do fun stuff like, right, you can make it sepia just with a parameter in the URL. So, you know, it's a fun tool to play with. I like showing it off because it's like easy live demos, right? Just generate images on the fly. So there are a lot of different ways you can do this sort of image optimization. There's similar tools that will do all of that for video if you're interested in optimizing your video. Yeah.
Speaking of video, when you mentioned, you know, change animated GIFs to MP4, is that what Giphy is essentially doing, or GiphyCat, I think it is?
So yeah, so if you ever go to Giphy, I had that heck of a time creating my slides because I wanted a GIF to show it next to the animated WebP, to show it next to the movie. But if you ever go to their webpage and you try to download stuff, it's always, if I'm using Chrome, it comes down as an animated WebP or it comes down as the MP4. Like, it's doing all of that. It's doing all of that automatically for you. So yes, if you ever link to like Giphy or any of those other GIF websites, they're changing it for you on the fly too. If you think about it, that makes sense because it's their bandwidth costs, right? And if they can serve all of their content at like 5–10% the bandwidth, it's saving them money. So.
All right, there's one.
Oh, one more.
Do you also have some secret sauce for infographics? What you optimize the image, but still keep the text visible, readable?
So, are you doing your infographics in SVGs, or it all depends on how you're building your infographics?
Well, it's usually the clients, they just create infographics and they send it in different formats. Some sending PNGs, some sending PDFs.
So if you have a PNG, switching it to a WebP and doing the quality stuff, it should still work and it won't make the text look bad. You should still be able to optimize the quality, lowering the quality to it so that the fonts still look great on your infographics. So that should still work. You may not be able to lower it, like the quality auto may be closer to 85 or 90 quality. You may not be able to squeeze as much out because you want those fonts still to look really nice. And usually when you lower the quality, you start to see the jaggies and text faster than you do in other things. There are ways to go further than that if you have them as SVGs and other formats. But if you just have it as a PDF, all of the techniques I talk about here will work. You just might not be able to squeeze them as small as other types of files.
Another thing, could you, on the browser, go to where the PDF is? Because it's not there on the website or...
It was on the meetup page.
I didn't see it in the meetups.
All right.
I'm doing something wrong.
It's on meetup.com, yes.
Meetup.com. If you want me to put them somewhere else, I can do that too. But they're all up on SlideShare. My SlideShare is Doug Sillars. So if you go to SlideShare and search for Doug Sillars, again, I think there's a chef in Glasgow with the same name as mine. But other than that, there are no other Doug Sillars on the internet.
Probably not as much on the internet.
No, he isn't. We connected on LinkedIn because, like, why not? But yeah, cool. Awesome. I'll hang around for a little bit, and so we can still chat if you guys are still interested.
Yeah, thank you so much.